In this lecture, we are going to talk about the possibility of time travel, whether it is possible or impossible to time travel. In order to address the issue, let's start with the question: what should an interesting time travel be? Well, traveling across time zones is surely not an interesting time travel. Like I said, traveling across time zones is usually not considered as time travel. This is especially the case when you travel across the international date line. What happens when you travel across the international date line? Well, you gain a calendar day or you skipped a calendar day. But that is not what we usually consider as time travel. Remembering past events, that is, mental time travel, like remembering your childhood times, is clearly not enough for time travel. This kind of talk is merely metaphorical. How about having visions of the past or future? Like when people have superpowers, they can see or hear future things or past things. Well, merely having visions of the past or future is not enough for time travel. Why? Because the relevant experiences may be of the past, but they are not taking place in the past. So, merely having visions of the past or future is like receiving causal messages from the past or the future. It's different from actually present in the past or future. It's different from your experiences taking place in the past or the future, right? So merely having visions of the past or future is not enough. What about this one? Being asleep for 20 years, one's experiences will be internally indiscernible from those of a time traveler who disappears from one time and then reappears 20 years later. Why are their experiences internally indiscernible? Because after falling asleep or after entering a time machine, the next experience will be 20 years later. So in this aspect, the two situations, falling asleep and time traveling, are the same with regard to their internal experiences. However, going to sleep is not enough to make a time traveler. Why? Because, for example, Sleeping Beauty's body is present throughout the entire period. What about this one? Captain America. Being cryostasis, having suspended animation, that is, bodily processes being stopped. Would Captain America be considered as a time traveler? Well, in a sense, Cape America is just like Sleeping Beauty, right? Entering cryostasis is like falling asleep, and the next experience would be, say, 20 years later. So in this case, Cape America and Sleeping Beauty are the same with regard to their internal experiences, right? Only that in the case of Cape America, the bodily processes are stopped, meaning that when awake, Cape America wouldn't get any older like Sleeping Beauty. But with that difference affect their status of not being a time traveler? Apparently not. Well, what's interesting is this one. The case of continuous time travel into the future. Well, this can be considered as a mode of time travel. So in this case, like the movie, The Time Machine, the time traveler, Alex, does not disappear when the machine is turned on. Rather, he simply stays where he is while everything around him speeds up. But in a sense, this looks like Cape America, right? Why? Because everything around a time traveler, according to this mode of time travel, speeds up. But that's just a relative motion, right? So it can also be considered as the time traveler's bodily or physical processes are slowed down relative to everything around the time traveler, right? So in this sense, it is similar to Cape America. So now think, are both Alex, the time traveler in the movie The Time Machine, and Cape America time travelers? Are they both time travelers? Or are both not time travelers? Or only one of them is a time traveler? Is it Alex or Cape America? What do you think? What's your intuition? Well, if your intuition is that only Alex is a time traveler, then you may ask yourself, why? Why is that? What's the difference between the two kinds of cases? And why this difference makes one time traveler? Well, this is what's the case according to the book. Because for Cape America, the rates of the fundamental atomic processes are unchanged, even though his biological processes are kind of stopped or slowed. But the fundamental atomic processes are unchanged. So time travel consists in a discrepancy between personal time and external time at a fundamental physical level. All right. It's not in virtue of the difference between Cap America and Alex. We need to revise our original definition of time travel. So we not only consider time discrepancy between personal time and external time on the biological level, we also consider the discrepancy between personal time and external time at the fundamental physical level, right? Because on the biological level, Alice and Cap America may be indiscernible, right? Both of them are not getting any older during time travel. But at the fundamental physical level, there is a difference. In the case of Alex, the time machine, the fundamental physical process of the time machine itself, of the Alex, are slowed down. But in the case of Cap America, the fundamental physical processes are not slowed down, right? Why? Because you can simply put a clock within the cryostasis machine with just by Cap America. So while Cap America is not getting any older, the clock still ticks in a normal rate. So that says that the fundamental physical processes remains unchanged, right? So there is a difference between the two. According to David Lewis, time travel occurs only if, and in that case because, there is a discrepancy between external and personal time. But what is external time, what is personal time, and what is a time discrepancy? Let's suppose a time traveler initiates her time machine and then a minute later arrives 100 years in the past. So the departure of the time machine and the arrival of the time machine are separated by 100 years according to our normal timeline. So there is a time discrepancy. Two events, the time traveler's departure and its arrival, are separated by unequal amounts of time, or in different order. So in this case, the two events are separated by only 1 minute according to the time traveler's personal time. Right? So in this case, two events are not only separated by unequal amounts of time, but also in different order. Why? Because according to this personal evolution of events, the arrival of the time machine and the time traveler is later than the departure. However, according to the eternal time, the ordinary timeline, the departure is later than its arrival. So the two events are separated in different order. So an object's personal time is the alternative assignment of temporal coordinates to stages that matches the underlying causal relation. So this stage is caused by its earlier stage, and this is caused by this, and this is caused by that. And finally, the departure of the time machine causes its arrival in the past. So according to this causal sequence, according to this causal ordering, this is an earlier event and this is a later event in personal time. Okay, now let's consider this kind of time travel, which is called retrograde time travel. In which case, a time traveler persists through time in a backward direction, while a normal object persists through time in a forward direction. And this is what happens in the movie Tenet. Alright? So, like this car, the car, or the person within the car is a time traveler. And it's a causal process, it's a physical process. It's called a chain. It's reversed in the sense that it persists through time in a backward direction. Alright? So relative to a normal object which persists through time in a forward direction, the causal process, the physical process of this car is reversed. Now the question is this really physically realistic? Think about it. I'm not giving you answers right now. Well, now let's consider another mode of time travel, which is called discontinuous time travel, in which case a time traveler teleports from a later time to an earlier time without traveling through the intervening interval, like the movie Looper. Alright? So in this case, why is it a discontinuous time travel? Look at this. There is no sign of the appearance of this time traveler, right? There is no sign. The time traveler just comes out of nowhere, right? So that is considered as discontinuous time travel. The time traveler simply disappears from a time and then immediately reappears at another time. And since there is no traveling through the intervening interval, there is no intervening processes connecting two moments of time. So the time traveler appears without any sign in advance. Alright? It just appears. It just comes out of nowhere. Now, here's the question. Is this kind of time travel really physically realistic? Think about it. Alright, so let's consider this final mode of time travel, which is more physically realistic. This is backward or forward time travel in general relativity, which is wormhole time travel. This is a wormhole. But in order to understand this kind of time travel, let's talk about a few things about general relativity first. What is general relativity? Well, fixed point P in space-time. We can compute the curvature of space-time around P and measure the mass density of matter around P. Then, according to general relativity, the curvature of space-time geometry around P is proportional to the mass density of matter in space-time around P. Alright? So there's a relationship between the curvature of space-time and mass density of space-time. And this is so-called Einstein's field equations in the most simplified form. Right? So one reading of this equation is that there's really no mass of matter in space-time. There's really no gravity. It should be reduced to the curvature of space-time. There's only curvature of space-time, alright? Or at least there's a relationship between the two, right? You may think curvature of space-time is caused by mass density of matter in space-time. That's fine. But in any way, there is no gravity, alright? There's just mass and curvature of space-time standing in a relation to each other. But there is no gravity because there's just curvature of space-time. Gravity, the force of gravity is totally reduced to curvature of space-time. Alright, so in general relativity, there is no force of gravity. There's just, curvature of space-time. So the trajectory of this object is not explained by the force of gravity. Alright, the cause of this kind of trajectory is not explained by the force of gravity produced by this object. It is explained in terms of the curvature of space-time. Okay. Now, what's interesting is that the trajectories of free fall motion is the one that's subject to only gravity. So in a sense, this is a free fall trajectory, right? The trajectories of free fall are straight lines in a curved space-time. So again, this is counterintuitive according to our Euclidean intuition. All right, it looks like a curved trajectory, but that's because we have a kind of Euclidean glasses. In reality, in general relativity space-time, this trajectory is actually straight. Okay, that is, there are inertial trajectories. They are not subject to any force, external force. since there's no force of gravity, remember? So there are inertial trajectories, so there are straight lines. Their trajectories are straight. So now, what is a wormhole? Well, it's an additional structure that connects two areas of space-time. In this space-time diagram, right, there's a two-dimensional object. All right, only two dimensions. Why? Because this is a two-dimensional hypersurface. It's a two-dimensional surface, okay? One dimension of space and one dimension of time, right? So there is only one spatial dimension, and this is temporal dimension, all right? So let's consider this trajectory. So it changes its spatial position over time. So its trajectory is like this. Okay. Now, this two-dimensional space-time is has an additional structure like this. Why? Imagine there is a super huge mass around this area. So it curves the local space-time so that it creates an additional structure connecting this area of this part of space-time and that part of space-time. Okay? Now let's consider this trajectory. It's from here to there, proceeds through space-time, and finally reaches this wormhole. And then it goes through the wormhole to this point, to this area, and proceeds along this trajectory. Okay. Now, there is a time discrepancy between what? Apparently, let's consider this point P and this point Q. The personal time, that is, the temporal order along this trajectory, is according to this temporal ordering along this trajectory. Point P is earlier than point Q, right? So this is the personal time of this physical process. According to this personal time, according to this temporal ordering, P is earlier than Q. But now, since this is a Minkowski spacetime, right? Q has a Lycan structure. And let's suppose P, the point P, is within the future Lycan of Q. That means that the point P is time-like related to Q. And since it is within the future Lycan of Q, it is in the future of P, in the Lycon future. Sorry about that. The point P is in the Lycon future of Q, meaning that the point P is later than Q. So according to the personal time, Q is later than P. But according to Lycon time, P is later than Q. Okay, so there is a time discrepancy between Lycon time and personal time. So according to David Lloyd's definition, this can be considered as time travel. So that's basically what a wormhole is according to general relativity. Now, what does a wormhole look like from the inside and from the outside? Well, from the inside, according to a lot of movies, this is what a wormhole looks like. And from the outside, a wormhole should be observable. And since a time traveler traveled through a wormhole, there should be a sign of time traveler's arrival, right? It would go out of a wormhole, and through the wormhole, since it connects to another part of the space-time, we should see something through the wormhole about another part of space-time, like this. Okay, so this kind of scenario is a wormhole time travel. It's not like the one in discontinuous type of time travel. Now, finally, we can get to the grandfather paradox. According to Wasserman, the book, the textbook, the author of the textbook, the first clear statement of the grandfather paradox is due to Hugo Gernsback. According to him, the story goes, suppose I can travel back in time and thus enabled to shoot my grandfather while he is as yet married, sorry about the typo, as yet armed and unmarried. So it's totally possible to shoot grandfather. I could have but the consequence is that I could have prevented my own birth, right, by shooting my grandfather before he gave birth to my father, and so that prevents my own birth. Consequently, the idea that a time traveler can freely participate in activities of a former age becomes an absurdity, right? Can you see that? Since if my own birth is prevented, how come I can travel back in time to kill my grandfather, right? So that's a paradox. Here is a further formulation of the grandfather paradox, according to Wasserman. Right? If backward time travel were possible, then you would be able to travel back in time and kill your grandfather before your father was ever conceived, before your father was ever born, right? But in that case, you will not be born. And in that case, you will not be able to travel back in time to kill your grandfather, right? So, killing your grandfather, then your father wouldn't give birth to your father, then you will not be born, and then you wouldn't be able to kill your grandfather. Hence, if time travel were possible, you both could and could not kill your grandfather, and this could and could not constitute a paradox, right? Constitutes a contradiction. Since this result is contradictory, time travel must be impossible. So that's the so-called grandfather paradox against the possibility of time travel. Now, David Lewis again. He asked the question, if a time traveler both could and couldn't change the past, couldn't kill one's grandfather, then there cannot possibly be such a time traveler? David Lewis' answer is no. But we'll talk about that in a few lectures. Here's the story David Lewis provides. So, in the first place, you may wonder why would one kill one's grandfather, right? Now, consider Tim. He hates his grandfather, whose success in the munitions trade built the family fortune. Now, Tim wants so much to kill grandfather because he thinks munitions trade is unjust. So Tim builds his time machine using the family fortune and travels into the past. He then buys a rifle. He spends long hours in target practice. He shadows grandfather to learn the route of his daily walk to the munitions works. He rents a room along the route, and there he lurks, rifle loaded, hate in his heart, as grandfather walks closer and closer. Now, think, is it true that Tim has what it takes to kill grandfather? It seems so, right? Conditions are perfect in every way. The best rifle money could buy, grandfather, an easy target, only 20 yards away, not a breeze, doors securely locked against intruders. Tim is a good shot to begin with, and is now at the peak of training, and so on. In order to strengthen that point, the ability for Tim to kill his grandfather, consider another person, Tom. Suppose that down the street, another sniper, Tom, lurks waiting for another victim, grandfather's partner. Tom is not a time traveler, but otherwise he is just like Tim. Same make of rifle, same murderous intent, same everything. Same purpose to stop munitions trade. Now think, is it true that there's no doubt that Tom can kill his victim? It seems so, right? But if that's so, Tim has everything going for him that Tom does. So Tim has the skill, the means, the opportunity. He has the desire and resolve. So by any ordinary standards of ability, Tim can kill grandfather. Tim is as much able to kill grandfather as anyone ever is to kill anyone, right? So Tim could kill his grandfather. But again, if Tim could kill his grandfather, Tim wouldn't be born. Consequently, Tim wouldn't be able to kill his grandfather. And the contradiction thereby produced. Alright, so there's another more extreme version of the type, which is called the Infanticide paradox, meaning that traveling back in time and killing one's younger self. Alright? And it can also be called retro suicide paradox. This is not exactly what happens in killing oneself, but you get the idea. Now you may think, if killing one's younger self, or killing one's grandfather will result in a contradiction, why don't we do some other things other than killing one's younger self or one's grandfather by time travel? Well, according to Wasserman, saving a life can be just as problematic. So for example, in the movie The Time Machine, the time traveler Alex builds a time machine in order to prevent the death of his wife in the past. Alright? But in this case, saving a life is just as problematic. Why? Think about it. Why? Why is it just as problematic? Because the only reason for building a time machine is to prevent the death of his wife in the past. So if Alex successfully saved his wife from the murder, he wouldn't have the purpose for building a time machine, right? And then he wouldn't be able to save his wife. So again, the same type of contradiction emerges. So, according to Wasserman, the author of the textbook, each of the foregoing cases involves a self-defeating act, whether it's killing one's younger self, killing one's grandfather, or even saving a life. Alright? So a self-defeating act means an act such that if it were performed, it would not be performed. So it's self-defeating. Self-defeating acts are obviously impossible, since the performance of such an act would imply a contradiction. So the grandfather paradox, the retro suicide paradox, according to Wasserman, are a kind of the paradox of self-defeat. Now you may think, saving a life or killing one's younger self may endanger one's purpose to build a time machine. Now, maybe we can do some other things other than anything that could endanger our purpose to build a time machine, right? So for example, We can just travel back in time just to witness the extinction of dinosaur, just to witness what caused the extinction of dinosaurs, right? So how about traveling into the past just to witness an event? That wouldn't endanger anything about building a time machine, right? Now, but assume that you weren't there to witness the event, all right? So according to our world history, according to universe model, all right, there's just one timeline, and so there's just one version of the history, and in that world history you weren't there to witness the event. So then even a mere short presence by traveling back in time to witness an event will be a past altering act, since you weren't there to witness the event, right? So you are traveling back in time to witness an event, resulting in a short presence at that moment. But you weren't there. Your presence at that moment was not in the history. So your presence by traveling back in time would be a past altering act. It would be changing the past, right? That is, traveling back in time to witness an event, given that you weren't there to witness the event, it would be an act that would make the past different from how the past actually is. But according to widely accepted principle, we cannot change the past. It's impossible to change the past. Why? Because the past is what has happened. You can make what has happened not have happened, right? So there's only one version of history. The history is already made. There's just one history. There's just one version of facts, right? There are facts about the past. They are just facts. The facts cannot be changed. Otherwise, they wouldn't be facts, right? So, but you may wonder, why not? Because if facts can be changed, that would produce an obvious contradiction. Make something that happened not have happened, or make something happen that did not, resulting a contradiction like P and not P, where P stands for any proposition, like, so for example, Lincoln was assassinated, right? But if you change the past, you would create another fact, that is, it is not the case that Lincoln was assassinated because Lincoln was saved. So and incompatible facts equally obtain. That is, Lincoln was assassinated, and it's not the case that Lincoln was assassinated. And that constitutes an obvious contradiction. And any form, like any proposition that has this form, P and not P, is a logical contradiction. and logical contradiction is impossible. It is not something possible to happen in the universe. So it's impossible to change the past, because in the one timeline model, because changing the past in one timeline model would produce a logical contradiction. However, scenarios of changing the past in a lot of sci-fis suggest that the same event occurs twice, with the first one being changed. Right? So according to the principle that it is impossible to change the past in one timeline model, this idea is a fallacy, which can be called the second time around fallacy, because there's only one occurrence of any event in block universe like this, right? This is just one event, another event, another event, yet another event. There is just only one occurrence of any event in block universe, and it is this occurrence of any event that constitutes the whole universe, right? It's what constitutes the universe. Just an events like this. It's just, it's just one event. Event is something that's fundamental, cannot be changed. It's just like an atom, right? If you change that atom, then it will be another universe. It's not the same universe, but there's only just one universe, right? So in this block universe model, in this one timeline model, changing the past is impossible. So it's impossible to travel back in time, even just to witness an event, all right? Even just to be there for a very short period of time. All right, so a better understanding of time travel and this block universe model is this. All right. Well, actually, it's just a better understanding of time travel. Travel into the past either did or did not happen, because there's, just one universe. There's just one world history. Travel back in time either happened or did not happen. Right? If it happened, it happened. You cannot change that. If it did not happen, then again, then there's no way to travel back in time, because it did not happen. Now, assume that time travel happened. All right, just that we haven't found any evidence for that, but in reality, it happened. Now, we can further assume that a time traveler did not kill his grandfather. All right, because this is how this world in fact works. No one's born without a grandfather, right? So, as a matter of fact, the time traveler did not kill his grandfather. But we can still ask such valid question. Can the time traveler kill grandfather? All right. So this question is not a question about changing the actual world. All right? The correct understanding of time travel is not to consider the question about changing the actual world. All right? By asking this question, can a time traveler kill its grandfather? It's not a question about changing the past of the actual world. It's not that we are attempting to change the past. It's a question instead about the ability of changing the past. It's about the ability to kill one's grandfather or kill one's younger self or do anything else. All right? So for example, as a matter of fact, we didn't do something, but that doesn't mean that we didn't have the ability to do that thing, right? We didn't do something doesn't mean just because we didn't do something doesn't mean we didn't have the ability to do that thing, right? So we can still consider our ability to kill grandfather, given that we didn't kill grandfather, but we can still consider whether we have that ability, right? Or possibility. So question like this is a question about possibility, about possible worlds, whether there could be another possible world in which we killed our grandfather in the first place. Would there be such possible worlds? Would there be a kind of possible world in which a time traveler appeared in the past, witnessing the extinction of the dinosaur? Would that kind of world be possible? All right. Or it can be a question about timelines. All right. Maybe there are some other timelines other than the actual one, the one where we inhabit, right? So this is the correct understanding of time travel, assuming that time travel happened and we didn't do something. Now we can still ask questions about whether we have the ability to do something, whether there are possible worlds where we did something, or where there were different timelines, or different hyper times in which we did something. All right, and these will be the topics of the following lectures. And here is David Lewis' solution to that contradiction, to that paradox. He says, right, Tim could kill grandfather in the ordinary sense, and Tim couldn't kill grandfather, but that's in another sense. That's in the logical sense. All right, so even though Tim both could and couldn't kill grandfather, but Tim could in one sense, but couldn't in a totally different sense. So there's nothing contradictory. The basic idea of this solution is that what I can do relative to one set of facts, I cannot do relative to another more inclusive set. That's pretty common, right? So for example, an ape cannot speak Finnish, but I can. Relative to facts about the anatomy and operation of the human larynx and nervous system. So relative to these facts, I can speak Finnish, whereas an ape cannot. An ape does not have the ability. However, that set that that set of facts does not take me alone. Does not make me have the actual ability to speak Finnish. All right. So don't take me alone to Helsinki as your interpreter because I cannot speak Finnish. So here, I don't have the ability to speak Finnish relative to another set of facts. The facts that I haven't learned how to speak Finnish. Okay. So in one sense, in this sense, I do have the ability to speak Finnish, but in another sense, relative to another set of facts, I don't have the ability to speak Finnish. Okay, so likewise, a time traveler could change the past in a practical or ordinary sense, but couldn't change the past in the logical sense. That's David Lewis' basic idea. So therefore, there is no contradiction. There is a contradiction only when both could and couldn't change the past in the same sense. Okay, but here, since they are in different senses, there is no direct contradiction. Therefore, backward time travel is possible. All right, so here's the discussion topic for this lecture. With regard to traveling back in time, doing something, is saving one's life as problematic as killing one's younger self? According to Wasserman, the answer is affirmative. But think about it. You may have a different answer.